Hello everyone. In this video we're going to be solving a radical exponential equation. We have square root of 5 plus 2 to the power x plus square root of 5 minus 2 to the power x equals 18, and we're going to be solving for x values. I'll be presenting two methods and then I'll show you a graph. Let's start with the first method. So for my first method, I want you to notice, and we're also going to use this idea for the second, but if you multiply square root of 5 plus 2 and square root of 5 minus 2, from difference of two squares you get 5 minus 4, which is equal to 1. So in other words, these two expressions are reciprocals. That's nice, so we can write square root of 5 minus 2 as 1 over square root of 5 plus 2. And now this allows us to express this term in terms of the first one. So let's go ahead and do the following. Replace the square root of 5 minus 2 with 1 over square root of 5 plus 2. So it's going to give us square root of 5 plus 2 to the power x from the original equation plus 1 over square root of 5 plus 2 to the power x equals 18. And obviously this calls for substitution, right? Doesn't it? So we're going to go ahead and call this something. How about u? If you call that u, we get the following equation. U plus 1 over u equals 18. This can be turned into a quadratic equation. Multiply both sides by u. You get u squared plus 1 equals 18u. And u squared minus 18u plus 1 equals 0. Now this quadratic equation can easily be solved either by completing the square or by using the quadratic formula, and the roots are 9 plus minus 4 root 5. Okay, so we have two solutions. Let's go ahead and check each one. Are both of them valid? First of all, that's what we gotta check. So we said that a square root of 5 plus 2 to the power x equals u. And this is equal to 9 plus 4 root 5. I'm going to start with the positive one, the plus 1, and then I'll use the minus 1. Now, if you forget about the u totally and just set this equal to 9 plus 4 root 5, does this work, right? And it does, actually, because 9 plus 4 root 5 is square root of 5 plus 2 squared. Now, how do I know that? Well, I do know that because I kind of came up with this problem, but if you square this expression, you're actually going to get 9 plus 4 root 5. Now, why am I squaring? Because that gives me 9 plus 4 root 5. That makes sense, right? If it didn't, then I would probably cube it. So x equals 2 seems to be a solution from here, but the question is that the only solution, right? So that's what we're going to check. So notice that square root of 5 plus 2 to the power x can also be set equal to 9 minus 4 root 5 because we have two solutions to this quadratic equation, remember? So we have to check both. Now, 9 minus 4 root 5 is positive, so it's good. And you know that this can be written as square root of 5 minus 2 squared, just like the other one with a minus sign. Now, how can I associate it with root 5 plus 2? Because these are different bases, right? But remember, those are reciprocals. So I can write the root 5 minus 2 squared as 1 over root 5 plus 2 squared. So these are equivalent because root 5 minus 2 is 1 over root 5 plus 2, so we can square both sides. And then this means square root of 5 plus 2 to the power negative 2 by definition of the reciprocal or the negative exponent. So we got the following. Let's rewrite it. Square root of 5 plus 2 to the x equals square root of 5 plus 2 to the power negative 2, which implies x equals negative 2 is another solution. And that's the only other solution, so we got two solutions for this equation. Make sense? Okay, great. So let's go ahead and take a look at the second method, and then we'll take a look at the graph. Okay? Second method. Second method is obviously very similar to the first. I just use a slightly different approach. So now, by using the binomial theorem, I can safely say that square root of 5 plus 2 to the power x, if x is an integer, of course, right, can be written as a plus b root 5. So when you expand it with any power of x, where x is a positive integer or non-negative integer, well, not negative, not true, but it's supposed to be positive. You're going to get some integers, and you're going to get multiples of root 5. And you can put them together, and you're going to get the following structure. Make sense? So this implies that I can do the same thing with a minus sign, and then this time the coefficient of root 5 is just going to be negative b instead of b, because everything will be negated that has square root of 5 in it. Make sense? So we can go ahead and do the following. We can go ahead and add these equations together. When we add them, we get square root of 5 plus 2 to the power x plus square root of 5 minus 2 to the power x equals, these two cancel out, and we end up with 2a. But we do know that the left-hand side is equal to 18. It's given, right? So this is equal to 18. What is that supposed to mean? It means a is equal to 9. It's good. So we got half of it. Since a is equal to 9, we can basically say that root 5 plus 2 to the power x equals 9 plus b root 5, and square root of 5 minus 2 to the power x is 9 minus b root 5. Okay. Now, how do I know it's a plus b root 5, but not, or a minus b root 5, but not like something a root 5 minus b, right? You might be questioning. If you add these two expressions, you still end up with a radical. Make sense? But you have to get rid of the square root of 5, so you can end up with an integer like 18. That's why we have to write it this way. So now, instead of adding them, we're gonna multiply them this time. When we multiply these two things, obviously the bases are going to be multiplied, but remember they are reciprocal, so it's kind of going to look like this: root 5 plus 2 times root 5 minus 2 all to the power x equals 9 plus b root 5 times 9 minus b root 5, which can be written as 81 minus 5b squared from difference of two squares. Difference of two squares is super duper important. These two are reciprocals, remember, so their product is 1. 1 to the power x is 1, so from here we get 81 minus 5b squared equals 1, and 5b squared equals 80, b squared equals 16, and b equals 4, or b equals negative 4. Well, b equals negative 4 doesn't really give you anything different, so we can take b to be positive. It doesn't matter. It's just going to be switched around. So b equals 4 is okay, and that means we have square root of 5 plus 2 to the power x equals 9 plus 4 root 5 as before. The difference between the first and second method is we didn't solve a quadratic equation. Well, we kind of did, but with the square roots, that was easier. So, you know, we got to the same answer, right? We arrived at the same thing. So now we can write the 9 plus 4 root 5 as square root of 5 plus 2 squared as before. And from here, x equals 2 works. But I want to show you something. Why does negative 2 also work? We've seen with the first method why it does, but let me go ahead and explain it a little differently. So if x equals 2 is a valid solution, then I can just plug it in, right? So it should give me 18. And you can easily check that. Very easy to check, right? But let's go ahead and do the following. Root 5 plus 2 is the reciprocal of root 5 minus 2. So I can write it like this. And root 5 minus 2 is the reciprocal of root 5 plus 2, vice versa. I can write it like this. And this is 18. And it kind of helps me to write it in a different way. Root 5 minus 2 to the power negative 2. And then root 5 plus 2 to the power negative 2 equals 18. I'm just going to switch these two terms, even though it doesn't matter. Just to, you know, show you what this looks like. So I'm just going to switch these two because they're being added, doesn't matter. And now remember, the original problem, the original equation was this one. And what does that tell you? That tells you that, oops, I was supposed to replace with x. Okay. So this tells you that negative 2 is also a solution, because look at this, right? X equals negative 2 works. Therefore, x equals negative 2 is also a solution. And let's go ahead and take a look at the graph real quick. So I graphed this for you, even though these are exponentials. They kind of undo each other in such a way that you get this symmetrical graph. Obviously, that makes sense, because if x equals z is a solution, then negative z is also a solution. As you can see, 2 and negative 2 are solutions. And those are the only solutions. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.